Hello guys, here we will learn the video based on the analysis of current series negative feedback amplifier. So as far as current series negative feedback is considered, we have to learn the output resistance, input resistance and the gain factor of this particular topology of negative feedback amplifier. Let's look at the particular name, that is current series negative feedback amplifier. Here from the name itself you should get to know that which kind of sampling, which sampling parameter, which kind of mixing and which mixing parameter is included in this particular feedback amplifier. First of all, you should get to know that current name is there. So first name always and always will be of the form of sampling. So sampling is of the form current. Okay, so what we will say, sampling is of the part, किसका sampling है, current का sampling, and whenever I will do current sampling, always and always that sampling should be in series circuit, right? So series circuit at the sampling part. As far as mixing is considered, mixing which is given as the part of the circuit is given in the form of series network, right? So whenever I'm saying it's a series mixing, then which parameter I have to include? I have to include the parameter as voltage. So this is the voltage and this is your series. So with these two factors series, I will get to know that how your connection should look like. Okay, parameter at the output side is a series combination, parameter is current but the combination circuit is series circuit, and the parameter at the input side is voltage and the connection is still series only. Okay, so we'll try to draw this circuit. Pause your screen, you also try to draw that particular circuit and tally with my circuit. Pause your screen. I hope you have drawn this perfect circuit. I know that you guys are very brilliant guys. So let's tally this particular circuit, my circuit with you, so your circuit. So let's start with this tallying the circuit. So this is nothing but your series combination at the input side. Rs is very less as compared to Ri, and this is your total voltage supply, that is Vs. This is the voltage that we'll be getting at the feedback. Feedback is in the form of voltage, so because mixing is in the form of voltage, so that's why I've written over here Vf. This is nothing but the Vi, that is input voltage. I will get the value at the output is of the parameter current. So I will be getting, this is nothing but the value of the output voltage, output current, that is IO. So your value of the output is I and the value at the input is V. So what will be the type of this amplifier? Yes, this is nothing but your transconductance amplifier. So this will be your transconductance amplifier. As far as transconductance amplifier is considered, we have to use the word GM, right? GM into the value VI, input parameter, that is VI. GM into VI is equal to IO. If you carefully see this particular circuit, this circuit resembles with your AC equivalent circuit of BJT and JFET, where we have considered the RPi model, and this is nothing but your input resistance, that is RPi, and GM VGS or GM Vpi that we have considered is nothing but same as that of this particular circuit. So there we have used the transconductance for part of this transconductance amplifier part of this circuit. So this is your value RL, that is load resistance. This is RO, this is RI, this is RS. Now what will be the value of B? B is nothing but the output parameter and input parameter ka ratio, right? Output parameter is VF as far as this feedback is considered. So I can say that VF divided by IO. Clear? Very simple phenomena. Mathematics is involved in this particular part only. Only we have to consider that which parameter is there for the mixing, which parameter is there for the sampling, and which part of the circuitry we have to use, whether series or whether shunt. So depending on that, we have to draw this particular circuit. Once we draw this circuit, it will be very simple to analyze this circuit as far as input resistance, output resistance and gain part is considered. Here we have to assume that what is gain of this particular amplifier circuit. So I will say that open loop gain. Here for the transconductance, open loop gain I will consider it as GM. GM is nothing but the value of IO. As we have said that RO is very high, so current will not flow through this RO. I can say IO is same as that of current GM into VI. So I can say this GM into VI is equal to IO, then GM will become IO divided by VI, and that is nothing but the output current to the input voltage. If this particular feedback is not present, that means VF is equal to 0. If VF is equal to 0, VS is itself acts as VI, because here itself I know that RS is very small in value. So this is open loop gain, and this is also called as the gain without feedback. Okay, so this is nothing but your gain without feedback. Now we'll have to move ahead to find out the value of the gain with feedback. So let's start. We have to understand that gain with feedback, I will name this as it's nothing but GMF, okay, with feedback, and that is nothing but gain with feedback. I have to consider that my output parameter will remain as it is, that is IO, but instead of VI I have to consider it as VS. So I can say that if GM is equal to, if only GM, that is open loop gain, if it is equal to IO divided by VI, then GMF will be equal to IO divided by VS. IO divided by VS is nothing but the value of GMF. Now let's start with the analysis, exact analysis. Here we have got this particular ratio, and I get to know that I want this ratio at the end. Once we get this particular thing, we done with this particular gain with feedback part. Okay, let's analyze this. We'll start at the input side. As we have done in voltage series negative feedback circuit, here also we'll repeat the same thing. Vs is equal to Vi plus Vf. So we'll start applying the KVL at the input. So we'll say apply KVL at input. If we apply KVL at the input, we'll be getting Vs is equal to Vi plus Vf, right? But here it's a magic that Vi, what's a Vi? Vi will get from this particular circuit, this particular part of the circuit. GM into Vi is equal to IO. So I will get to know that what is Vi? Vi is equal to IO divided by GM. So first part we'll get Vi is equal to IO divided by GM, and we'll be getting what is the value of Vf? Vf is nothing but from this feedback circuit we'll be getting that Vf is equal to B into IO. So we'll be getting B into IO. In this particular formula, we'll get to know that this Vi and Vf are in the form of current IO. So I can take this IO outside and we'll get to know what will be the value of Vs. Vs is equal to IO into 1 plus GM into B divided by GM. Okay, I want the ratio IO divided by Vs, so I will do the inverse part. So nothing but IO divided by Vs is equal to GM divided by 1 plus GM into B. That is nothing but your value GMF, and this is nothing but the required formula for the gain with feedback. So this is the required formula for gain with feedback. We'll say it's nothing but So we done with the first part, that is gain with feedback. Okay, now we will move towards the second part, that is nothing but the input impedance with feedback. It's a simple to know that input impedance with feedback, if I want to calculate, I have to first know what will be the input impedance without feedback. So we'll write that input impedance without feedback is nothing but Ri. Let's see this particular circuit. You also will get to know that what will be the value. As this particular current is constant, current will be same for Rs as well as Ri. I can say Vs divided by Ii is nothing but the value. Vi divided by Ri is nothing but the value of the resistance without feedback. So if I'm not considering this feedback, Vs itself will act as Vi only. So here we will say Ri is nothing but Vi divided by Ii, right? Quickly find out the ratio. What will be the ratio? In which parameter I will get that particular ratio for input impedance with feedback? So we'll write input impedance with feedback. I will note it as RIF, F for feedback, and instead of Vi only I will write Vs. That's it. Because current is same, I will treat this current as same as that of I only. Will not change because series connection at the input side. So let's start with the KVL at the input only. Apply KVL at input. We'll get to know that Vs is equal to Vi plus Vf, right? We'll directly jump to the formula of Vf directly. I will not repeat it again. What's the value of Vf? Vf is nothing but the value B into IO, right? So B into IO is nothing but the value of Vf. Okay, but what's the value of IO? IO is nothing but Gm into Vi. So I will write that formula Vi plus B. What's the value of IO? IO is nothing but Gm into Vi. Okay, so here if you want to, you can write it in a bracket that IO is equal to Gm into Vi, and I can say here you can write it as Vf is equal to B into IO. Okay, I can take this Vi outside. Vi 1 plus B into Gm. Simple. This is nothing but your value Vs. From these two equations, we will get to know that Ri into Ii is nothing but Vi, and Vs is equal to Rif into Ii. Okay, so we'll put these values over here. We'll get to know that Rif into Ri, and Vi is nothing but Ri into Ii, and here we will be getting the value of input resistance with feedback. I mar gaye. I can say that RIF is equal to Ri into 1 plus B into Gm. So here I can conclude that your input resistance increases by factor 1 plus Gm into B. Clear? So this is nothing but the second formula that we are expecting for input resistance with feedback. So here we will write it as input impedance rather with feedback. Now the last part is remaining, that is nothing but output resistance impedance. Will write with feedback. Okay, very important task that you have to mention it over here. That is what you'll have to mention. Connection is mixing is in series, so we have to short your power supply at connected at the input side, and we have to connect another power supply at the output side. So we'll say connect external voltage supply Vx at output, right, and short circuit input source Vs. Basically we are replacing this Vs by its internal resistance. So your circuit will look like this. Will be your short circuited. This will be, I will not represent whole, I will just represent it in the form of Gm is equal to IO divided by Vi. Okay, and this is in series connection. Okay, and this is B is equal to Vf divided by IO. This IO is over here, right? This is RL. A simple connection that we have to understand, the fact that here we have to connect the Vx. Okay, see to it that we will draw this circuit again for your analyzing at the output side output impedance. So how we will be drawing this particular output side only? This output side, this will become your Gm into Vi. Okay, this will be your output resistance. Okay, and this will be your Vx which has been connected. Okay, clear? As far as this is nothing but your current source. So what I will do, I will say it's nothing but one load resistance will be there into picture, right? And I can say this is nothing but your current Ix, right? Considering the fact that we are considering these at KCL at the output side, we'll say that node number A, and we will say this is how we will be getting the we'll be drawing the half part of this particular circuit, and we will say this at this particular node A we will apply the KCL. So we'll say apply KCL at node A. If we apply KCL at node A, we will get to know that this is the incoming current. Okay, this is the incoming current, right? This is the outgoing current, and this is also the outgoing current. Okay, so here I can say Ix plus Vx divided by Ro is nothing but the current flowing through Ro. So we'll write it over here, Vx divided by Ro. Okay, simple, is equal to the Gm into Vi. Which parameter is to be neglected, which is to be converted into another form? It's nothing but Vi, right? Moreover, I know that I have to do the short circuit at the input side. So we have done the short circuit at the input side. So our conclusion is that whatever Vi I will be getting, that is exactly same as that of Vf as far as magnitude is considered. So here my conclusion is Vi is equal to minus of Vf, right? So what we will do, as Vs is equal to 0, we will write Vi is equal to minus of Vf, right? If Vf is of minus sign, then we will be getting Vf is nothing but, what's the value of Vf? Vf is nothing but B into IO. Okay, and as I know that what's the value of IO? IO is nothing but the inverse of that of your Ix. Okay, so let's put this value of Vi in this particular equation. So what we will be getting? Ix plus Vx divided by Ro is equal to minus Gm into B into IO. Okay, so let's start with the calculation of Vx and Ix. So by solving this particular equation, we'll get to know that the value of Ix plus Vx divided by Ro, here we'll be getting minus Ix is equal to Gm, oh no, it's a plus Gm into B into Ix. So let's take this Gm, B and Ix at this side. We'll be getting that this is your Ix in bracket 1 plus Gm into B is equal to Vx divided by Ro with minus sign. Okay, so I know that as Ix is equal to minus of Io, right? So whatever Io I have to consider is in the form of this. This is nothing but the value Io. This is exactly in opposite direction. So you can say that whatever value I will be getting for Vx divided by Io is in the form of Ro multiplied with 1 plus Gm into B. Very simple. And that is nothing but the value of, I can say this is nothing but the value ROF, right? ROF. It's nothing but the output resistance. Yes. So final value we have got that the output resistance with feedback is nothing but increased value to that of your output resistance without feedback. Output impedance, this is with feedback. Okay, as far as all the three values are considered, we got that the gain factor is reduced, input resistance increases, output resistance as well increases, right? So we'll form a conclusion part. So your conclusion for this particular circuit is nothing but make a table and then we'll decide that these are nothing but the parameters. This is without feedback and this is with feedback. Okay, first parameter that we'll be getting is nothing but gain, and that gain is in the form of transconductance. We'll write it in the bracket as Gm. Here also the notation is Gm only, and that Gm is nothing but the value of Io divided by Vi. Okay, here we will be getting Gmf is nothing but Io divided by Vs, and that is nothing but Gm divided by 1 plus Gm into B. Okay, that B value is also different for each and every topology. Keep this in mind. That second parameter that we have to consider it as input impedance. Okay, that input impedance is Ri, where Ri is nothing but Vi divided by Ii. Okay, and here we have to consider Rif with feedback is nothing but Vs divided by Ii, that comes out to be Ri multiplied by 1 plus Gm into B. Clear? Third part is left. Now output impedance, that just now we have covered. Output impedance is Ro, which is equal to Vx divided by Io. Similarly, it is equal to, we can say ROF is equal to V, here it is VO divided by IO, and here it is nothing but Vx divided by IO. This is coming out to be Ro divided by 1, it's not divided by, it's multiplied by only 1 plus Gm into B. Okay, clear? So now here my final conclusion is gain reduces, input impedance increases, and output impedance as well increases. right? So this is how we have learned the current series negative feedback amplifier analysis, where we have got the gain with feedback, where we have got the gain, we have got the input impedance with feedback, we have got the output impedance with feedback, and we have end up with the current series negative feedback analysis. So here we will stop. We will learn the final analysis for negative feedback topology in the next video. So stay tuned for that and learn more and more EDC along with me, along with Ekeeda videos. Subscribe this particular channel of Ekeeda. Thank you so much.